Welcome back to my 3D printer build log. Today I'll assemble and test the vertical axis and the main frame of the printer. From top to bottom, I'll need the head assembly, the bed level bracket, the motor assembly and the foot bracket, all attached with T-slot nuts. I'll also have to mount the carriage on the rail and attach the timing belt. I'm starting with the lower end, first the bed level bracket, then the motor assembly and then the foot bracket. The T-slot nuts rest on the little tabs that reach into the maker slide extrusion. That makes it a lot easier to fix the components. The nuts on the back side will be used to install the outer enclosure later on, so only the screws on the sides are used to fix the brackets to the rail. The carriage needs to be installed before the head assembly. By adjusting the eccentric spacer, I can eliminate unwanted horizontal play. Now that the head assembly is installed, I can add the timing belt. I thread it through the idler and the motor bracket first, then fix it to the carriage. The carriage has two sets of blocks that hold the belt so that it loops back onto itself. This way it cannot move out under tension. I might add a cap to prevent the belt from wiggling itself loose later on. With the belt installed, I can easily adjust its tension using the M4 screw on the tensioner. Now there is a slight issue with the cabling. The end switch cable needs to be routed towards the lower end where all of the other cables are. I'm using the front slot of the maker slide extrusion as shown with this offcut. However, I need something to hold the cable in the slot and prevent it from getting into the way of the carriages. After some rather unsuccessful experiments with printed clips, I went for a very simple solution. Some strips of cardboard can easily hold the cable in place since there will be no tension at all involved. I first thread the cable through the slot out towards the top. This section of the cable will be routed in front of the cardboard strips. Then I insert the cardboard strips behind the cable, pulling them down the rail with some pincers. Next, I thread the cable behind the cardboard strips and pull it out at the bottom. Since the cardboard strips do not reach all the way up to the top of the rail, the cable can loop down inside the rail and does not stick out at the top. At the bottom end, I push a small loop of cable into the bed level bracket and pull the cardboard strip down to keep it in place. The horizontal extrusions are fastened using T-slot nuts as well. It's easier to install the screws and nuts like this before inserting the rails. For various reasons, I won't be placing the electronics underneath the print bed. For my arrangement, the stepper motor wires are much too short, so I add some additional cable to it. To stop the end switch cable from getting pulled out of the rail, I fasten the cables with some zip ties. The connection is wrapped in heat shrink tube for insulation. For the frame assembly, I found it easiest to first attach a set of horizontal extrusions to each vertical rail and then put together these three groups into the final frame. When tightening the screws, it's important to ensure that the horizontal extrusions are pushed into the brackets all the way, otherwise the frame will be warped. Before assembling the frame, I'm adding some T-slot nuts to the horizontal rails that I will use to mount the bed, the outer enclosure and some other stuff later on. To prevent the nuts from falling out of the last assembly when turning it with the extrusions pointing down, I used some temporary screws to hold them in place. I put an additional nut onto each of the foot screws, then screw the feet into the lowermost brackets. After leveling the frame, I used these nuts to lock the feet against the brackets. Off camera, I connected the motors and the end switches to the geared Wi-Fi that will control the entire printer. Here's a homing sequence and a simple test run. The printer mechanics are really quiet, although I had to put the frame onto some dampening material to prevent my workbench from humming along. The loud noise you can hear is a single fan inside the industrial power supply that I use to run the printer. I might have to replace that sometime, it really is annoyingly loud. That's it for today. In the next video I'll assemble the arms and install a temporary effector so that I can finally check the Delta mechanics. In the meantime, if you have any comments, please leave them below, and if you liked the video, please give it a thumbs up. And please subscribe to get notified of new videos. See you later!